Okay, hi guys. Today I'm on week 8, task 5, and I am going to tell you all about day 6 notes. And so we've already talked about 3 other types of reactions. We talked about synthesis, where things come together. We've talked about decomposition, where compounds are broken apart. We've talked about single replacement, where we had one metal, often it's a metal, it can be a non-metal as well, but bump out another one so that it then forms the compound. And today we're going to talk about the last two, a double replacement reaction and combustion. And so you can see here we're going to start with double replacement, okay? So double replacement. So when we're looking at this double replacement reaction, we often call that a DR, just for short. Two compounds react to form two new compounds, and this is all in your notes. So this is compound plus compound yields compound plus compound. I always describe this as square dancing. A plus B, or AB plus CD yields AD plus CB. They've just had a partner switch. So A and C are both girls, we'll say, and A goes with D, and C goes with B. You can see that in the results. So it's literally like square dancing, where the boys stood still for a minute, like you did in grade 6 or whenever you learned square dancing, and then the girls moved. Boop, over. So that's how I always think of double replacement reactions, okay? So you don't use activity series. In our level of chemistry, they just bump the other guy out. It's really simple, and they just move along. So the example on your slide is copper 1 sulfate plus beryllium oxalate yields. So all you know is that copper 1's the metal, beryllium's the metal. So you can see copper 1 is going with oxalate. Plus, I'm not going to have enough room here. Beryllium goes with sulfate. Okay? So all you've had is the switch. And you can do these out in chemical form, but I think that we'll get some practice on that on the worksheet. So for now, this is how it's explained on the PowerPoint. Okay? So there's another kind of double replacement reaction that's a bit specific. It's called a neutralization reaction. I'm going to write that down. Neutralization. Neutralization reaction. So this is a double replacement reaction where we have an acid plus a base. These two things react. Okay? And you always get water. That's always one of the byproducts. So I'm going to show you an example of this. So what they have here for an acid on the sheet, they have nitric acid plus aluminum hydroxide. All right, let's investigate this a bit more. Nitric acid. Let's get our little cheat sheet. Nitric acid. So it's an ick. Okay? Nitric acid is an ick. So what was it originally? Nitrate? All right. So we know it was nitrate. So hydrogen is always in the acid. And we know it was nitrate. So let's look that up on the polyatomic sheet. What does nitrate look like? I see it right here, NO3 minus 1. So it's hydrogen nitrate. That's the other name for nitric acid. Well, what does it look like? Well, a hydrogen's a +1. We just looked up nitrate right here. NO3 -1. HNO3. That's hydrogen nitrate. So I'm going to write him nicely here. HNO3. That's nitric acid plus aluminum hydroxide. Well, let's look at that down here in the scrap. Aluminum is a +3. Look him up on the periodic table. I just end up knowing most of these because I do it a lot. And then look, hydroxide. That's what hydroxide right here, OH negative. All bases, not all bases, but all bases at this level are made of hydroxide. OH is the base. Just like hydrogens make up acids, hydroxides make up bases. So when you crisscross this, you get Al, open a bracket, OH, close the bracket 3. So that's aluminum hydroxide. Al, open the bracket, close it, OH3. So when I have this guy and this guy, what am I going to get? So just a sec. I've kind of made a mess here, so I'm going to just do it up a little bit better here. Nitric acid, which can also be called hydrogen nitrate, HNO3 plus, I'm just making it a little smaller, aluminum hydroxide, which we figured was AlOH, close the bracket 3. What is that going to yield? So now I've just got it tidier. All I did was rewrite that over there. Okay. So hydrogen nitrate. Well, hydrogen's the metal. In here, aluminum's the metal. In a double replacement reaction, they literally swap places, right? This guy goes here, this guy goes here. So what do we end up with? Let's do the words right here. We do hydrogen hydroxide plus aluminum. And what did it go with? Nitrate. I wish that my stuff was bigger. Wish my screen was bigger. Okay. Hydrogen hydroxide. Well, what happens down here? Well, I can see the metals here is hydrogen and aluminum. So they are the ones that switch. The same that's up there. So here's a little scrap sheet. Hydrogen hydroxide. Well, hydrogen is a H+1. Hydroxide's OH -1. We just looked those up. That's HOH. What's HOH? I always tell you to write water that way. H2O is HOH. So hydrogen hydroxide is actually water. The fancy name is hydrogen hydroxide. So we're going to write HOH because I like to write HOH better. But tonight at dinner you could say, hey, can I have some hydrogen hydroxide, please? And people will think, like, what? And you're really just asking for water. So that's kind of funny. And then we have aluminum nitrate. Well, let's do some scrap down here. Aluminum is a +3. What do we think that nitrate was? We'll go look it up again if you need to. It's NO3 -1. So I get Al, open a bracket, NO3, close the bracket, 3. So I'm going to put that up here. Aluminum. So what ends up happening is you've just did a square dance. You've just taken the metals and they've switched partners. Boop, they switch partners. That's it. So now we look and we balance this. Well, our polyatomics didn't come apart. So that's awesome. If you treat OH, that's why I like to write water like this. Treat it like two separate things, the hydrogen and the hydroxide. So here I've got one hydrogen, here I've got one hydrogen. That's good. One NO3, 3 NO3s. So I better put a 3 out front here, right? And then when I look, I got to change this hydrogen to a 3 because this hydrogen just got changed. And then I've got 3 OHs and 3 OHs, and I'm done. Okay? So this is called a neutralization reaction because we ended up neutralizing an acid and a base, and in a neutralization reaction we get water, which is hydrogen hydroxide. So that's an example of that. That's on your PowerPoint. Okay? So another little thing about predicting products, and I'm going to show you this little chart that is on your sheet. The next type, so that was all double replacement. We're going to go over two types of two types of reactions today. The last type of reaction, so you've done synthesis, decomposition, single replacement, double replacement, and now I'm on combustion. Last type, combustion. And you might have heard of combustion. It's a reaction with oxygen. O2, or oxygen. Okay? So you might know on a side of a can, something says something's combustible. That's what it means. And there's a little chart in your, on this slide that says if your reactant contains this will be your results. If your reactant contains a carbon, the product will be CO2. So if the reactant contains carbon, a product, when it's reacted with oxygen, will be CO2. If the reactant contains hydrogen, the product will be H2O. If the reactant contains sulfur, the product is SO2. If the reactant contains nitrogen, the product will be N2. So this is a little chart I would have had you study. This is in your PowerPoint. You can copy it down from me if you want and set it to the side and use it for availability so we can check to predict products. So I'm going to set this little chart to the side and then I'm going to continue on and do some of the reactions with you guys. All right, so this is an example of a combustion. CH4 plus O2. Okay, so how do I know what's going to be here? Well, if I contained a carbon, I get a CO2. I have a carbon. If I contained a hydrogen, I get water. Boom, done. These guys have different rules. There's no replacement. You have to know this chart or use it for a reference so you know if you have what you have plus oxygen, which is what makes it a combustion. Whatever you have in your reactants, you'll know your products based on the rules. Okay, so then you go through and balance it. One thing about these to balance, these get tricky. I'm going to do this one with you guys. And the one thing that you guys should know is you should always leave the O2 to the end. Okay, always leave the O2 to the end. Let's balance this because these are a little tricky. So I've got carbon, I've got hydrogens, and I've got oxygens on each side. Carbon, hydrogen, oxygens. Always leave the O2 by himself because he's alone and he doesn't affect anybody else once you've changed it. So that's always a good tip for these. So on this side I got one carbon, on this side I've got one carbon. That was easy. This side I've got 4 hydrogen. On this side I've got 2 hydrogen. On this side I've got 2 oxygen. On this side, 1, 2, 1, 2, 3. I've got 3. All right. So what do I do here? Oh, sorry. I've got 2 hydrogen here and 4 here. Okay, yeah, I do. So let's leave oxygen to the last. So I'm going to put a 2 here and make this hydrogen be 4, which also affects my oxygen. So that means I have 4, right? 2 here and 2 here. So that's good. So I got my hydrogens good. My carbons are good. Let's go back and look at my oxygens. So I've got 4 on this side, 2 on this side. So if I put a 2 here, I have 4. And I'm balanced. Okay? So you should just always leave the O2s to the end. All right. There's another slide here that used H3N. Let's do this combustion. This is combustion. 3N plus O2 yields what? Well, let's go look. If our reactant contained hydrogen, we're going to get a water. If our reactant contained nitrogen, we're going to get nitrogen by itself. Oops, sorry, my pen went flying across the room. Hang on. So we get nitrogen by itself, and it's diatomic. It's one of our super 7, so it looks like that. Now we got to balance this. These can be tricky. We're going to leave the O2 to the end. There's some tricks involved in balancing some of these harder ones. So let's look. I've got hydrogen on this side, nitrogen, oxygen, hydrogen, nitrogen, oxygen. How many hydrogen here? I've got 3. I've got 1 nitrogen, and I've got 2 oxygen. On this side, I've got 2 hydrogen, 2 nitrogen, and 1 oxygen. So when we go through, let's look. So, start off with my hydrogens. I'd like to, between 2 and 3, I've got to make these numbers 6. So if I'm going to make this 6, I have to put a 3 here. 2 times 3 is 6. And 3 for my oxygen. So if I got 6 on this side, I got to make this side a 2. 2 times 3 is 6. And 2 for my nitrogen. So that's good. So these guys are right, these guys are right, and these guys are not right. So I've got 2 on this side and 3 on this side. So what am I going to do next? 2 and 3. What do I do? Here's what I really would like to do. I would really like to do a half of this, right? So I'm allowed to do it for a second. If I said I would really like to do, what times 2 would give me 3? 1.5? I would really like to put a 1.5 there. 2 times 1.5 would give me 3. I would be balanced, but I'm not allowed to put a 0.5 there. But it's a good strategy in the middle. I'm allowed to put it there for a second and be like, perfect, I'm balanced. So now to get rid of that 1.5, I multiply everybody by 2. So 2 times 2 is 4. 2 times 1.5 is 3. 2 times 3 is 6. 2 times 1 that was here is 2. That's a quick way to balance. You can put in what you really want and then multiply it all out, and you got rid of the decimal. And this is balanced, and it's right. And it's just a good little tip on how to balance those harder ones. I'm trying to see what else is on these slides as I click through. So I try to teach you it as we go. Nope, that's the end. Okay, so that's it. I'll be helping you with the worksheet in a bit. Let me know if you need me. Okay, bye.